Unit 3, Chapter 6, Water Resources. Do you think that what exists today will continue to be so, or the future is going to be different in some respects? It can be said with some certainty that the societies will witness demographic transition, geographical shift of population, technological advancement, degradation of environment and water scarcity. Water scarcity is possibly to pose the greatest challenge on account of its increased demand coupled with shrinking supplies due to overutilization and pollution. Water is a cyclic resource with abundant supplies on the globe. Approximately 71% of the Earth's surface is covered with it, but freshwater constitutes only about 3% of the total water. In fact, a very small proportion of freshwater is effectively available for human use. The availability of freshwater varies over space and time. The tensions and disputes on sharing and control of this scarce resource are becoming contested issues among communities, regions, and states. The assessment, efficient use and conservation of water, therefore, become necessary to ensure development. In this chapter, we shall discuss water resources in India, its geographical distribution, sectoral utilization, and methods of its conservation and management. Water resources of India. India accounts for about 2.45% of the world's surface area, 4% of the world's water resources, and about 16% of the world's population. The total water available from precipitation in the country in a year is about 4,000 cubic km. The availability from surface water and replenishable groundwater is 1,869 cubic km. Out of this, only 60% can be put to beneficial uses. Thus, the total utilizable water resource in the country is only 1,122 cubic km. Surface water resources. There are four major sources of surface water. These are rivers, lakes, ponds and tanks. In the country, there are about 10,360 rivers and their tributaries longer than 1.6 kilometers each. The mean annual flow in all the river basins in India is estimated to be 1,869 cubic km. However, due to topographical, hydrological and other constraints, only about 690 cubic km, 32% of the available surface water can be utilized. Water flow in a river depends on size of its catchment area or river basin and rainfall within its catchment area. You have studied in your class sheet textbook, India, Physical Environment, that precipitation in India has very high spatial variation, and it is mainly concentrated in monsoon season. You also have studied in the textbook that some of the rivers in the country like the Ganga, the Brahmaputra, and the Indus have huge catchment areas. Given that precipitation is relatively high in the catchment areas of the Ganga, the Brahmaputra and the Barak rivers, these rivers, although account for only about 1/3 of the total area in the country, have 60% of the total surface water resources. Much of the annual water flow in South Indian rivers like the Godavari, the Krishna, and the Kaveri has been harnessed, but it is yet to be done in the Brahmaputra and the Ganga basins. Groundwater resources. The total replenishable groundwater resources in the country are about 432 cubic km. The level of groundwater utilization is relatively high in the river basins lying in northwestern region and parts of South India. The groundwater utilization is very high in the states of Punjab, Haryana, Rajasthan, and Tamil Nadu. However, there are states like Chhattisgarh, Odisha, Kerala, etc., which utilize only a small proportion of their groundwater potentials. States like Gujarat, Uttar Pradesh, Bihar, Tripura and Maharashtra are utilizing their groundwater resources at a moderate rate. If the present trend continues, the demands for water would need the supplies. And such situation will be detrimental to development and can cause social upheaval and disruptions. Lagoons and backwaters. India has a vast coastline and the coast is very indented in some states. Due to this, a number of lagoons and lakes have formed. The states like Kerala, Odisha and West Bengal have vast surface water resources in these lagoons and lakes. Although water is generally brackish in these water bodies, it is used for fishing and irrigating certain varieties of paddy crops, coconut, etc. Water demand and utilization. India has traditionally been an agrarian economy, and about 2/3 of its population have been dependent on agriculture. Hence, development of irrigation to increase agricultural production has been assigned a very high priority in the 5-year plans, and multipurpose river valleys projects like the Bahakar Nangal, Hirakud, Damodar Valley, Nagarjuna Sagar, Indira Gandhi Canal Project, etc., have been taken up. In fact, India's water demand at present is dominated by irrigational needs. Agriculture accounts for most of the surface and groundwater utilization. It accounts for 89% of the surface water and 92% of the groundwater utilization. While the share of industrial sector is limited to 2% of the surface water utilization and 5% of the groundwater, the share of domestic sector is higher, 9% in surface water utilization as compared to groundwater. The share of agricultural sector in total water utilization is much higher than other sectors. However, in future, with development, the shares of industrial and domestic sectors in the country are likely to increase. Demand of water for irrigation. In agriculture, water is mainly used for irrigation. Irrigation is needed because of spatio-temporal variability in rainfall in the country. The large tracts of the country are deficient in rainfall and are drought-prone. Northwestern India and Deccan Plateau constitute such areas. Winter and summer seasons are more or less dry in most part of the country. Hence, it is difficult to practice agriculture without assured irrigation during dry seasons. Even in the areas of ample rainfall like West Bengal and Bihar, breaks in monsoon or its failure creates dry spells detrimental for agriculture. Water need of certain crops also makes irrigation necessary. For instance, water requirement of rice, sugarcane, jute, etc. is very high, which can be met only through irrigation. Provision of irrigation makes multiple cropping possible. It has also been found that irrigated lands have higher agricultural productivity than unirrigated land. Further, the high-yielding varieties of crops need regular moisture supply, which is made possible only by developed irrigation systems. In fact, this is why that Green Revolution strategy of agriculture development in the country has largely been successful in Punjab, Haryana and Western Uttar Pradesh. 220. Fig. 6.1 India River Basins. In Punjab, Haryana and Western Uttar Pradesh, more than 85% of their net sown area is under irrigation. Wheat and rice are grown mainly with the help of irrigation in these states. Of the total net irrigated area, 76.1% in Punjab and 51.3% in Haryana are irrigated through wells and tuber wells. This shows that these states utilize large proportion of their groundwater potential, which has resulted in groundwater depletion in these states. The overuse of groundwater resources has led to decline in groundwater table in these states. In fact, over-withdrawals in some states, like Rajasthan and Maharashtra, has increased fluoride concentration in groundwater, and this practice has led to increase in concentration of arsenic in parts of West Bengal and Bihar. Activity.tif. Intensive irrigation in Punjab, Haryana and Western Uttar Pradesh is increasing salinity in the soil and depletion of groundwater irrigation. Discuss its likely impacts on agriculture. Emerging water problems. The per capita availability of water is dwindling day by day due to increase in population. The available water resources are also getting polluted with industrial, agricultural and domestic effluents, and thus, in turn, is further limiting the availability of usable water resources. Deterioration of water quality. Water quality refers to purity of water, or water without unwanted foreign substances. Water gets polluted by foreign matters, such as microorganisms, chemicals, industrial and other wastes. Such matters deteriorate the quality of water and render it unfit for human use. When toxic substances enter lakes, streams, rivers, ocean and other water bodies, they get dissolved or lie suspended in water. This results in pollution of water, whereby quality of water deteriorates, affecting aquatic systems. Sometimes, these pollutants also seep down and pollute groundwater. The Ganga and the Yamuna are the two highly polluted rivers in the country. Activity.tif. Find out which are the major towns, cities located on the bank of the Ganga and its tributaries and major industries they have. Water conservation and management. Since there is a declining availability of freshwater and increasing demand, the need has arisen to conserve and effectively manage this precious life-giving resource for sustainable development. Given that water availability from sea, ocean, due to high cost of desalinization, is considered negligible, India has to take quick steps and make effective policies and laws, and adopt effective measures for its conservation. Besides developing water-saving technologies and methods, attempts are also to be made to prevent the pollution. There is need to encourage watershed development, rainwater harvesting, water recycling and reuse, and conjunctive use of water for sustaining water supply in long run. 221. Prevention of water pollution. Available water resources are degrading rapidly. The major rivers of the country generally retain better water quality in less densely populated upper stretches in hilly areas. In plains, river water is used intensively for irrigation, drinking, domestic and industrial purposes. The drains carrying agricultural, fertilizer and insecticides, domestic solid and liquid wastes and industrial effluents join the rivers. The concentration of pollutants in rivers, especially, remains very high during the summer season when flow of water is low. The Central Pollution Control Board (CPCB), in collaboration with state pollution control boards, has been monitoring water quality of national aquatic resources at 507 stations. The data obtained from these stations show that organic and bacterial contamination continues to be the main source of pollution in rivers. The Yamuna River is the most polluted river in the country between Delhi and Etawah. Other severely polluted rivers are the Sabarmati at Ahmedabad, the Gomti at Lucknow, the Kali, the Adyar, the Coam entire stretches, the Vagai at Madurai and the Musi of Hyderabad, and the Ganga at Kanpur and Varanasi. Groundwater pollution has occurred due to high concentrations of heavy toxic metals, fluoride and nitrates at different parts of the country. The legislative provisions such as the Water Prevention and Control of Pollution Act 1974 and Environment Protection Act 1986 have not been implemented effectively. The result is that in 1997, 251 polluting industries were located along the rivers and lakes. The Water Cess Act, 1977, meant to reduce pollution, has also made marginal impacts. There is a strong need to generate public awareness about importance of water and impacts of water pollution. The public awareness and action can be very effective in reducing the pollutants from agricultural activities, domestic and industrial discharges. Recycle and reuse of water. Another way through which we can improve fresh water availability is by recycle and reuse. Use of water of lesser quality such as reclaimed wastewater would be an attractive option for industries for cooling and firefighting to reduce their water cost. Similarly, in urban areas, water after bathing and washing utensils can be used for gardening. Water used for washing vehicle can also be used for gardening. This would conserve better quality of water for drinking purposes. Currently, recycling of water is practiced on a limited scale. However, there is enormous scope for replenishing water through recycling. 71. Activity.tif. Observe the quantity of water used at your home in various activities and enlist the ways in which the water can be reused and recycled in various activities. Class teachers should organize a discussion on recycle and reuse of water. Watershed management. Watershed management basically refers to efficient management and conservation of surface and groundwater resources. It involves prevention of runoff and storage and recharge of groundwater through various methods like percolation tanks, recharge wells, etc. However, in broad sense, watershed management includes conservation, regeneration and judicious use of all resources natural, like land, water, plants and animals, and human within a watershed. Watershed management aims at bringing about balance between natural resources on the one hand and society on the other. The success of watershed development largely depends upon community participation. The central and state governments have initiated many watershed development and management programs in the country. Some of these are being implemented by non-governmental organizations also. Haryali is a watershed development project sponsored by the central government which aims at enabling the rural population to conserve water for drinking, irrigation, fisheries and afforestation. The project is being executed by Gram Panchayats with people's participation. Neeru Meru Water and You program in Andhra Pradesh and Arvari Pani Sansad in Alwar, Rajasthan have taken up constructions of various water harvesting structures such as percolation tanks, dugout ponds, Johad check dams, etc. through people's participation. Tamil Nadu has made water harvesting structures in the houses compulsory. No building can be constructed without making structures for water harvesting. Watershed development projects in some areas have been successful in rejuvenating environment and economy. However, there are only a few success stories. In majority of cases, the program is still in its nascent stage. There is a need to generate awareness regarding benefits of watershed development and management among people in the country, and through this integrated water resource management approach, water availability can be ensured on sustainable basis. Rainwater harvesting. Rainwater harvesting is a method to capture and store rainwater for various uses. It is also used to recharge groundwater aquifers. It is a low-cost and eco-friendly technique for preserving every drop of water by guiding the rainwater to borewell, pits and wells. Rainwater harvesting increases water availability, checks the declining groundwater table, improves the quality of groundwater through dilution of contaminants, like fluoride and nitrates, prevents soil erosion and flooding, and arrests saltwater intrusion in coastal areas if used to recharge aquifers. Rainwater harvesting has been practiced through various methods by different communities in the country for a long time. Traditional rainwater harvesting in rural areas is done by using surface storage bodies, like lakes, ponds, irrigation tanks, etc. In Rajasthan, rainwater harvesting structures locally known as Kundur Tanka, a covered underground tank, are constructed near or in the house or village to store harvested rainwater. See Fig. 6.3 to understand various ways of rainwater harvesting. There is a wide scope to use rainwater harvesting technique to conserve precious water resource. It can be done by harvesting rainwater on rooftops and open spaces. Harvesting rainwater also decreases the community dependence on groundwater for domestic use. Besides bridging the demand-supply gap, it can also save energy to pump groundwater as recharge leads to rise in groundwater table. These days rainwater harvesting is being taken up on massive scale in many states in the country. Urban areas can specially benefit from rainwater harvesting as water demand has already outstripped supply in most of the cities and towns. Apart from the above-mentioned factors, the issue desalinization of water, particularly in coastal areas, and brackish water in arid and semi-arid areas, transfer of water from water surplus areas to water deficit areas through interlinking of rivers can be important remedies for solving water problem in India. Read more about interlinking of rivers. However, the most important issue from the point of view of individual users, household and communities is pricing of water. Watershed development in Ralegan Siddhi, Ahmednagar, Maharashtra, a case study. Ralegan Siddhi is a small village in the district of Ahmednagar, Maharashtra. It has become an example for watershed development throughout the country. In 1975, this village was caught in a web of poverty and illicit liquor trade. The transformation took place when a retired army personnel settled down in the village and took up the task of watershed development. He convinced villagers about the importance of family planning and voluntary labor, preventing open grazing, felling trees, and liquor prohibition. Voluntary labor was necessary to ensure minimum dependence on the government for financial aids. It socialized the costs of the projects, explained the activist. Even those who were working outside the village contributed to the development by committing a month's salary every year. 222. Work began with the percolation tank constructed in the village. In 1975, the tank could not hold water. The embankment wall leaked. People voluntarily repaired the embankment. The 7 wells below it swelled with water in summer for the first time in the living memory of the people. The people reposed their faith in him and his visions. A youth group called Tarun Mandal was formed. The group worked to ban the dowry system, caste discrimination and untouchability. Liquor distilling units were removed and prohibition imposed. Open grazing was completely banned with a new emphasis on stall feeding. The cultivation of water-intensive crops like sugarcane was banned. Crops such as pulses, oilseeds and certain cash crops with low water requirements were encouraged. 73. All elections to local bodies began to be held on the basis of consensus. It made the community leaders complete representatives of the people. A system of Nyay Panchayats, informal courts, were also set up. Since then, no case has been referred to the police. A 22 lakh rupees school building was constructed using only the resources of the village. No donations were taken. Money, if needed, was borrowed and paid back. The villagers took pride in their self-reliance. A new system of sharing labor grew out of this infusion of pride and voluntary spirit. People volunteered to help each other in agricultural operation. Landless laborers also gained employment. Today the village plans to buy land for them in adjoining villages. At present, water is adequate, agriculture is flourishing, though the use of fertilizers and pesticide is very high. The prosperity also brings the question of ability of the present generation to carry on the work after the leader of the movement who declared that the process of Ralegan's evolution to an ideal village will not stop. With changing times, people tend to evolve new ways. In future, Raleigh might present a different model to the country. 223. Fig. 6.3 Various methods of rainwater harvesting. Highlights of India's National Water Policy, 2002. The National Water Policy 2002 stipulates water allocation priorities broadly in the following order: drinking water, irrigation, hydropower, navigation, industrial and other uses. The policy stipulates progressive new approaches to water management. Key features include: irrigation and multipurpose projects should invariably include drinking water component, wherever there is no alternative source of drinking water. Providing drinking water to all human beings and animals should be the first priority. Measures should be taken to limit and regulate the exploitation of groundwater. Both surface and groundwater should be regularly monitored for quality. A phased program should be undertaken for improving water quality. The efficiency of utilization in all the diverse uses of water should be improved. Awareness of water as a scarce resource should be fostered. Conservation consciousness should be promoted through education, regulation, incentives and disincentives. Source: Government of India 2002, India's Reform Initiatives in Water Sector, Ministry for Rural Development, New Delhi. Activity.tif. Collect information about National Water Policy, 2012, and Ganga Rejuvenation from the website www.women.nic.in, and discuss in the classroom. Jal Kranti Abhiyan 2015-16. Water is a recyclable resource, but its availability is limited and the gap between supply and demand will be widening over time. Climate change at the global scale will be creating water stress conditions in many regions of the world. India has a unique situation of high population growth and rapid economic development with high water demand. The Jal Kranti Abhiyan launched by the Government of India in 2015-16 with an aim to ensure water security through per capita availability of water in the country. People in different regions of India had practiced the traditional knowledge of water conservation and management to ensure water availability. The Jal Kranti Abhiyan aims at involving local bodies, NGOs and citizens at large in creating awareness regarding its objectives. The following activities have been proposed under the Jal Kranti Abhiyan. 1. Selection of one water-stressed village in each 672 districts of the country to create a Jal Gram. 2. Identification of model command area of about 1,000 hectares in different parts of the country, for example, Up, Haryana, North Karnataka, Telangana, Tamil Nadu, South, Rajasthan, Gujarat West, Odisha East, Meghalaya, Northeast. 3. Abatement of pollution, water conservation and artificial recharge. Reducing groundwater pollution, construction of arsenic-free wells in selected areas of the country. 4. Creating mass awareness through social media, radio, TV, print media, poster and essay writing competitions in schools. Jal Kranti Abhiyan is designed to provide livelihood and food security through water security. Exercises. 1. Choose the right answers of the following from the given options. I. Which one of the following types describes water as a resource? A. Abiotic resource. C. Biotic resource. B. Non-renewable resources. D. Non-cyclic resource. E. Which one of the following South Indian states has the highest groundwater utilization in % of its total groundwater potential? A. Tamil Nadu. C. Andhra Pradesh. B. Karnataka. D. Kerala. E. The highest proportion of the total water used in the country is in which one of the following sectors? A. Irrigation. C. Domestic use. B. Industries. D. None of the above. Though, answer the following questions in about 30 words. I. It is said that the water resources in India have been depleting very fast. Discuss the factors responsible for depletion of water resources. E. What factors are responsible for the highest groundwater development in the states of Punjab, Haryana, and Tamil Nadu? E. Why the share of agricultural sector in total water used in the country is expected to decline? If. What can be possible impacts of consumption of contaminated unclean water on the people? 3. Answer the following questions in about 150 words. I. Discuss the availability of water resources in the country and factors that determine its spatial distribution. E. The depleting water resources may lead to social conflicts and disputes. Elaborate it with suitable examples. E. What is watershed management? Do you think it can play an important role in sustainable development?